Alright, I see all these parentheses and I want to take the derivative of this function, so that certainly tells me I'm going to have a lot of chain rules. So if you like the shortcut way, don't watch this video, watch the next one. This video is going to be writing out on the side, or I'm going to probably do it underneath here, the long way of breaking this down into a bunch of composite functions. So what I do is I look at the complete outside. So let's call that ln of something. Doesn't matter your variables. I'm going to use u. And now I'm going to be to this next inside. So let's call that next inside 5 secant of something. I don't know. How about v? And then let's get to the next inside, which would be my v equals 4 ln, again, of something. So I don't know, how about w? And now let's get another color. And so now I'm inside here. So my w would equal 12x squared. So you can see there's 1, 2, 3, 4 functions I'm going to take derivatives of. So the derivative of ln of u is 1 over u. The derivative of secant, because that 5 is just a constant that stays out front, is secant tangent. The derivative of ln, so the 4 is a constant, of ln of w is 1 over w. So let's do that. And then finally, the derivative of 12x squared is 24x. So the chain rule says take all of these pieces and multiply them. Well, as I'm going to do that, I'm going to start substituting things back. So the first one is 1 over u, and u is 5 secant v, where v is 4 ln of w, and w is 12x squared. So I just started substituting. You can kind of see what I'm doing is I'm going from here to here to here to here. Alright, so now the second piece here is 5 secant v, where v is 4 ln of w. Tangent v, where v again is 4, oh I'm sorry, I said w and I wrote w. Moan back, moan back, moan back, bam, bam. Let's go ahead and say what w is. So 4 ln of w, which is 12x squared. Then tangent of 4 ln of w, and w is 12x squared. Get some more room here. So now I'm on the 4 over w piece. So times 4 over w, and w is 12x squared. And then finally the 24x. So it looks pretty big and bad. However, this and that, because that's all being multiplied, can cancel. 12 can go into 24 2 times. I can cancel this 1x with that 1x on the bottom. So all I'm left with up top is 4 times 2, 8. The tangent piece, 4 ln of 12x squared, close, close. And then on the bottom, I just have 1x left over. Let's find the derivative of this function using the chain rule, doing it the shortcut way. So the shortcut way is basically just not writing down each individual composite function. So I look at the entire outside, and the derivative of ln of anything is 1 over the anything. So 5 secant 4 ln 12x squared. In other words, you leave the inside alone, times, I'm going to start working inside now. The derivative of 5, which is a constant, secant of anything is secant tangent. Many of you miss this piece of putting all this back inside here. I mean, a lot of you just put an X there, but you have to put everything in there. So it's secant tangent, and everything inside gets left alone. And then I'm inside here, so times 4 is my constant. The derivative of ln of anything is 1 over the anything. And then finally, my last piece, the derivative of 12x squared, 24x. So this is doing that whole y equals 1 over u equals 5 secant v, all that business. It's just not writing it down. And now I'm to the point where I can just start to see that cancels. 12 goes into 24 2 times. One of the x's cancel, so I'm left with 4 times 2, 8. I'm left with this business up top, tangent 4 ln 12x squared, and don't forget that lonely little x on the bottom.